Hello students, in this video I am going to show sums of surface areas and volumes from class 10 textbook. Here question number 1 is from 12.1. Two cubes each of volume 64 centimeter cube are joined end to end. Find the surface area of the resulting cuboid. Let me show how to do this sum. Now as given in the question, two cubes each of volume 64 centimeter cube are joined end to end. Find the surface area of the resulting cuboid. Here this is the first cube, this is the second cube. We have kept them side by side. And as given, the volume of this cube is 64 centimeter cube. Volume of this cube also 64 centimeter cube. We have to find the surface area of this cuboid. Now in case of each cube, we can consider let h be x centimeter. As given, volume of each cube is 64 centimeter cube, and we know volume of a cube is side cube, so x cube is 64. So x equal to cube root of 64. 64 is 4 cube, so x equals to 4. Now two cubes are placed side by side, so it forms a cuboid. Here length will be 4 plus 4, that is 8. Breadth will be 4, height also will be 4. So we can write, now two cubes are joined end to end to form a cuboid. So in resulting cuboid, length equals to 4 plus 4, 8. Breadth will remain 4, height will remain 4, because here only length is going to change, breadth and height will not change. So length will be 8, breadth will be 4, height will be 4. Now what is the formula for the surface area of the cuboid? Total surface area of a cuboid is twice LB plus BH plus HL. So twice L here is 8, B is 4, B is 4, height is 4, height is 4, length is 8. So 2, 4 is the 32 plus 16 plus 4 is the 32. If I add these 3, we are going to get 80. So 2 into 80, 160. Therefore 160 centimeter square is the surface area of the resulting cuboid. In question number 2, it is given a vessel is in the form of a hollow hemisphere mounted by a hollow cylinder. The diameter of the hemisphere is 14 centimeter and the total height of the vessel is 13 centimeter. Find the inner surface area of the vessel. As given, a vessel is in the form of a hollow hemisphere. This is the hollow hemisphere mounted by a hollow cylinder. So this is the cylindrical part. Diameter of the hemisphere is 14 centimeter and total height is 13 centimeter. We have to find the inner surface area of the vessel. So in case of hemisphere, diameter is 14. Since diameter is 14, radius will be half of it, that is 7 centimeter. In the cylindrical part, radius will be same because both of them are having the same diameter. So radius of cylindrical part also 7 centimeter, and height of the cylinder, since this is 14, radius is 7. If this part is 7, this also will be 7. So 13 minus 7 will be the height of the cylinder. So height of the cylinder is 13 minus 7, that is 6 centimeter. In the bracket you can write, since height of the hemisphere equal to radius of the hemisphere equal to 7, so this height is 7 centimeter. Now we have to find the inner surface area of the vessel. Now inner surface area of the vessel, we have two parts. One is cylindrical part, another is hemispherical part. To find the inner surface area of the vessel, we have to first calculate the curved surface area of the hemisphere and curved surface area of the cylindrical part. We know the curved surface area of hemisphere is 2 pi r square and curved surface area of the cylinder is 2 pi rh. From these two we can take 2 pi r common. 2 pi r common, we are left with r plus h. Now 2 pi is 22 by 7. Radius already we know it is 7. Radius is 7. Height is 6. You can write 7 plus 6 also. This 7 and this 7 can be cancelled. 2 into 22, 44. 6 plus 7, 13. 44 into 13 is 572. So 572 centimeter square is the total inner surface area of the vessel. Question number 3. A toy is in the form of a cone of radius 3.5 centimeter mounted on a hemisphere of same radius. The total height of the toy is 15.5 centimeter. Find the total surface area of the toy. As given, a toy is in the form of a cone of radius 3.5 centimeter mounted on a hemisphere of the same radius. The total height is 15.5 centimeter and we have to find the total surface area of the toy. Now in hemispherical part, here radius is 3.5 centimeter. In conical part, radius will be same, so radius will be 3.5, and here height, it will be 15.5 minus 3.5. 15.5 minus 3.5 is 12. Here you can write which is equals to 15.5 minus 3.5, which will give 12 centimeters. So in case of cone, radius is 3.5 and height is 12 centimeters. Since we have to find the curved surface area of this cone, formula is pi r L, so we have to calculate the slant height. For slant height, L equal to root over h square plus r square. Now L equal to root over 12 square plus 3.5 square. 12 square is 144, 3.5 square is 12.25. If you add these two, it will be 156.25. Now if you take the square root of 156.25, it will give 12.5. Therefore, slant height is 12.5 centimeters. Now we have to find the total surface area of this figure, which is the curved surface area of the cone plus curved surface area of the hemisphere. So we can write total surface area of the toy is the curved surface area of the cone plus curved surface area of the hemisphere. For cone, it is pi r L. For hemisphere, 2 pi r square. From here, pi r can be taken common. Then we are left with L plus twice r. Pi is 22 by 7. Radius 3.5. Slant height, we got 12.5 centimeter. L is 12.5 centimeter plus twice r, so 2 into 3.5. So this 3.5 and 7 can be cancelled. You will get 2. So 22 by 2 into 12.5 plus 3.5 to the 7. Now 22 by 2 will give 11 into 7 plus 12.5 will give 19.5. If you multiply these two, you are going to get 214.5 centimeter square. Therefore, total surface area of the toy is 214.5 centimeter square. Question number 4. A cubical block of side 7 centimeter is surmounted by a hemisphere. What is the greatest diameter hemisphere can have? Find the surface area of the solid. As given in the question, a cubical block of size 7 centimeter is surmounted by a hemisphere. What is the greatest diameter the hemisphere can have? Here, the diameter of the hemisphere will be same as edge. So we can write greatest diameter of the hemisphere is equal to the edge of the cube, which is 7 centimeter. So in case of cube, each edge is 7 centimeter, and in case of hemisphere, diameter is 7. So radius will be half of 7, that is 7 by 2 centimeters. To find the total surface area of the solid, we have to consider total surface area of the cube plus curved surface area of the hemisphere minus area of the circle. Here, circular part has to be removed, and there we have to place this hemisphere. So total surface area of this figure will be total surface area of the cube plus curved surface area of the hemisphere minus area of the circular part. Therefore, you can write surface area of the solid is total surface area of the cube plus curved surface area of the hemisphere minus base area of the hemisphere. Total surface area of the cube formula is 6 into h square plus curved surface area of the hemisphere is 2 pi r square minus base area of the hemisphere is pi r square. So 6 into 7 square plus 2 pi r square minus pi r square will give pi r square. So 6 into 7 square plus pi is 22 by 7 into r square, 7 by 2 into 7 by 2. 7 and 7 can be cancelled. 2 and 22 can be cancelled. It will be 11. So 7 square is 49. 49 into 6, 294 plus 11 into 7, 77 by 2. 294 plus 77 by 2 will be 38.5. So 38.5 plus 294 will give 332.5 centimeter square, which is the required surface area of the solid. Question number 5. A hemispherical depression is cut out from one face of a cubical wooden block such that the diameter of the hemisphere is equal to the edge of the cube. Determine the surface area of the remaining solid. Here it is given that a hemispherical depression is cut out from one face of a cubical wooden block such that diameter of the hemisphere is equal to the edge of the cube. We have to find the surface area of the remaining solid. Now in case of cube, suppose each edge is L unit, and in case of hemispherical depression, diameter will be L, so radius will be L by 2. To find the total surface area of the remaining solid, it is the total surface area of the cube plus curved surface area of the hemisphere minus area of the base, because this part we have to remove and there we have to make a hemisphere. So this part has to be removed, so it will be minus area of the base of the hemispherical part. Now curved surface area of the cube is 6 side square. Here side is L, so L square, plus in case of hemisphere curved surface area is 2 pi r square. Area of the base is a circle, so it will be pi r square. So it will be 6L square plus 2 pi r square minus pi r square will give pi r square. So 6L square plus pi, we know radius is L by 2, so L by 2 whole square. So 6L square plus pi L square, 2 square is 4. If you take 4 LCM, it will be 4 6 24 L square plus pi, 4 divided by 4 1, so it will be 1 into L square, L square. From these two I can take L square by 4 common. So if I take L square from the numerator and 4 from the denominator, so L square and 4 outside, we are left with 24 plus pi unit square. So this is the surface area of the remaining solid. 6, it is given a medicine capsule is in the shape of a cylinder with 2 hemispheres stuck to each of its ends as given in the figure. The length of the entire capsule is 14 mm and the diameter of the capsule is 5 mm. Find its surface area. A medicine capsule is in the shape of a cylinder with 2 hemispheres on the sides. The total length is given 14 mm and the diameter of the capsule is 5 mm. We have to find the surface area. So in case of hemispherical part, here diameter is 5 mm, so radius will be half of this, that means 5 by 2 mm. In case of cylindrical part, radius will be same as hemisphere, so it will be 5 by 2 mm and height will be 14, and this part is 5 by 2, this part is 5 by 2, so twice 5 by 2, so we can write height equal to 14 minus twice 5 by 2, so 2 cancel, 14 minus 5, 9. So surface area of the total capsule will be 2 into curved surface area of the hemispherical part plus curved surface area of the cylindrical part. 2 into curved surface area of hemisphere is 2 pi r square plus curved surface area of the cylindrical part is 2 pi r h. From these two we can take 2 pi r common. If we take 2 pi r common, we are left with twice r plus h. So 2 pi is 22 by 7 into radius is 5 by 2, twice radius is 5 by 2 plus height is 9. 2 and 2 cancel, 2 and 2 cancel. 5 into 22, 110 by 7 into 9 plus 5, 14. Now 7, 2 are 14, 2 into 110, 220. Therefore 220 mm square is the surface area of each capsule. In question number 7 it is given, a tent is in the shape of a cylinder surmounted by a conical top. If the height and diameter of the cylindrical part are 2.1 meter and 4 meter respectively, and the slant height of the top is 2.8 meter, find the area of the canvas used for making the tent. Also find the cost of the canvas of the tent at the rate of rupees 500 per meter square. As it is given that a tent is in the shape of a cylinder surmounted by a conical top. If the height and diameter of the cylindrical part is 2.1 meter and 4 meter and the slant height of the top is 2.8 meter, we have to find the area of the canvas. Now in case of cylindrical part, diameter is 4, so radius will be half of 4, that is 2 meter. The height of the cylinder is 2.1 meter. In case of conical part, radius will be same as cylinder. Here it is 2, so here also radius will be 2, and slant height already it is given 2.8 meter. Curved surface area of the cylinder plus curved surface area of the cone will give the area of the canvas. For cylinder it is 2 pi rh, for cone it is pi rl. From here I can take pi r common. If I take pi r common, twice h plus l. Pi 22 by 7, radius is 2, twice height is 2.1 meter plus slant height it is given 2.8 meter. Now 22 into 2, 44 by 7, 2 into 2.1 is 4.2 plus 2.8, so 44 by 7 into, if I add these two I will get 7, 7 and 7 will be cancelled, so we will get 44 meter square. Now it is given that cost of 1 meter square canvas is rupees 500 and we have to find the cost of 44 meter square. Therefore cost of 44 meter square canvas will be 500 into 44, which will give 22,000. Therefore 22,000 is the cost of canvas required to make the tent. In question number 8 it is given, from a solid cylinder whose height is 2.4 cm and diameter 1.4 cm, a conical cavity of the same height and same diameter is hollowed out. Find the total surface area of the remaining solid to the nearest centimeter square. Now as given, from a solid cylinder of height 2.4 cm and diameter 1.4 cm, a conical cavity of the same height and the same diameter is hollowed out. So we have removed this part. Find the total surface area of the remaining solid. We have to find in nearest centimeter square. So in case of cylindrical part, diameter is 1.4 cm. So radius will be half of it. Half means 1.4 by 2, that will give 0.7 cm. In case of conical part, radius will be same as the radius of the cylinder, which is 0.7 cm. Height will be same, 2.4 cm. Now we know the curved surface area of a cone is pi r L. L is slant height, so we have to calculate slant height. Slant height formula is root over r square plus h square. R is 0.7 square, h is 2.4 square. So 0.7 square is 0.49, 2.4 square is 5.76. After adding, it will be root over 6.25, which will give 2.5 cm. Therefore the slant height of the cone is 2.5 cm. Now we have to find the total surface area of this figure. For the total surface area, we require curved surface area of the cylindrical part, curved surface area of the conical part, and base of the cylinder. The total surface area of the remaining solid is curved surface area of the cylindrical part, curved surface area of the conical part, plus area of the cylindrical base. For cylinder it is 2 pi rh, for conical part pi rl, and for the base it is pi r square because base is a circle. From here I can take pi r common. So here twice h left, L left, here r is left. Pi is 22 by 7 into radius is 0.7, twice h, 2 into height is 2.4 plus L is 2.5. We already calculated L and radius is 0.7. 22 by 7 into 0.7 means 7 by 10. 2 into 2.4 will give 4.8 plus 2.5 plus 0.7. So this 7 and 7 can be cancelled. We are left with 22 by 10 into, if I add these 3, it will be 8. So 22 into 8 is 176 by 10, which will give 17.6 centimeter square. As given in the question, we need total surface area to the nearest centimeter square. Therefore total surface area of the remaining solid to the nearest centimeter square is 18 centimeter square. Question number 9. Wooden article was made by scooping out a hemisphere from each end of a solid cylinder. As shown in the figure, if the height of the cylinder is 10 centimeter and its base is of radius 3.5 centimeter, find the total surface area of the article. As given in the question, a wooden article was made by scooping out a hemisphere from each end. So from this part, hemispherical part is removed, from here also it is removed, and we got this figure. If the height of the cylinder is 10 centimeter and the base is of radius 3.5 centimeter, we have to find the total surface area of this figure. So in case of hemispherical end, it will be radius is 3.5 centimeter. In case of cylinder, height is 10 centimeter and radius is 3.5 centimeter. Now total surface area of this figure will be curved surface area of the cylinder plus 2 into curved surface area of hemisphere, because there are two hemispheres, so we have to multiply by 2. Curved surface area of the cylinder is 2 pi rh plus 2 into curved surface area of each hemisphere. We know curved surface area of each hemisphere is 2 pi r square, so it is 2 into 2 pi r square. 2 pi r common, h plus twice r. So 2 into 22 by 7 into radius is 3.5, height is 10 plus 2r, 2 into 3.5. So 22 into 3.5 into 2 will give 7 by 7 into 10 plus 3.5 to 7. This 7 and 7 can be cancelled. 22 into 10 plus 7, 17. So 22 into 17 will give 374 centimeter square. Therefore 374 centimeter square is the total surface area of this solid. And this is the last sum from 12.1. I hope all these sums are clear. Just practice these sums, and in my next video I am going to start from 12.2. Till then, bye bye, take care and wait for the next video.